Hey friends, MoNaCo here with our second homework video in our bonding unit. Today we're focusing on ionic versus covalent bonding and how the nature of the elements involved in the bond determine if the compound's going to be ionic or covalent and what these things kind of look like. So I need you to understand the difference between ionic and covalent bonds by the end of this video and understand essentially what basically a polyatomic ion is. And we're going to, at the end of the video, classify some bond types based upon those combinations that we're going to run through. Okay, so the first question to lead in here is what exactly is bonding and how many types of bonding are there? Well, there's three kinds of bonding: ionic, covalent, and metallic. That's it, three types. Each one has its own characteristics, and ionic and covalent are the major focus of this unit. Polyatomic ions are included in with ionic bonding because they are, well, ions. They have many atoms creating the ions, but they are in fact ions, so that are included in ionic bonding. It's also possible to classify a compound as ionic or covalent just by looking and seeing what types of elements, the nature of them, are combined. Okay. Here's a quick rundown of the two basic types of bonding we're going to be talking about. On the left, we have a sharing of electrons that make a molecule in a covalent bond. On the right, we have a transfer of electrons. See how the electrons moving from the atom on the left to the atom on the right, creating a positive ion and a negative ion, which we call an ionic bond. They kind of get attracted to each other and locked in because they're oppositely charged. Okay. So let's look at the two most common types of compounds. First, ionic. There's four different combinations of natures of elements and ions in order to make ionic bonds. So you got to know these four different combinations. The first scenario is the simplest, when a metal loses an electron to a nonmetal. The sodium, having one valence electron, will lose that electron to chlorine, and in the process become a sodium ion and chlorine ion. So we get an Na plus as a result and a Cl negative as a result. So these two opposites are attracted to each other, and we call that an ionic compound. Here's a picture of good old sodium chloride at the molecular level. Chlorine ions, sodium ions are kind of arranged in a nice crystal lattice structure. We get the nice salt crystals as a result. Now, if we go ahead and look at the second option, we got a metal combining with a polyatomic ion. If you look at this polyatomic ion, you've got nitrogen and oxygen in it, which are two nonmetals. So we really have a metal plus a nonmetal again. Except this nonmetal is in fact a polyatomic ion. There's a reference table E that will tell you about all of the different polyatomic ions that there are. We'll be studying that in more detail soon enough. Now, the third combination is when we get a polyatomic ion combining with a nonmetal. It's essentially the same as the second combination, except that the polyatomic ion is no longer a negatively charged one, but a positively charged one. And we'll notice we always like to put the positively charged stuff first, and it's attracted to a negatively charged thing. So again, ions with brackets around them get attracted to each other, making ionic compounds. The last scenario is when we have two polyatomic ions that are oppositely charged, attracted to each other to make an ionic compound, an ionic bond. That ionic bond is all about the positive and negative attraction coming to each other to make the compound. The other side of the fence, much simpler, because when you've got a covalent situation, covalent compound, you have two or more nonmetals sharing electrons. Just the nonmetals. There's only one scenario for covalent bonds: two or more nonmetals sharing electrons. Notice there's no brackets, there's no charges, there's no brackets, none of that business. We just have the elements that are nonmetals involved. We show a covalent bond by solid lines connecting physically the atoms together. We're getting more of that when we make our Lewis dot structures. So to classify a type of bond, we're going to say it's ionic or covalent. So you look back at your four examples, actually 5 examples of ionic versus covalent, and classify these as ionic, versus covalent. One of the two words will go into the box for your classification. Okay. Now, the last type of bonding is metallic bonding. It's not really bonding. It's kind of bizarre. The only way we can describe it is that metals share a sea of mobile valence electrons. It allows metals to conduct electric current and energy in a very, very easy way. I'm going to show you a visual picture of this because there's really no other way than to just kind of get a handle on the imagery. The free electrons from outer shells of the metal atoms kind of float around between the chunk, and the metal ions are kind of stuck and locked in place. So metals conduct heat and electricity because their outside valence electrons are so poorly held that they can travel between atoms very easily. And as a result, heat and electricity can be transferred between metallic atoms very, very quickly and very easily. So let's go back and wrap up here. All right. So at this point, you should be able to tell me the main differences between ionic and covalent bonds. Simply put, ionic bonds form when elements transfer electrons and get locked in place. And covalent bonds form when elements share electrons and therefore get locked in place. You should be able to predict what type of compound is made from the combination of elements or polyatomic ions now, like a metal plus a nonmetal makes an ionic compound, etc., those type of things. So at this point, you are ready to move on to your third homework video. Thanks for watching.